Okay, after finishing the drawing details, we're gonna design it ourselves. We go to new and you choose sheet metal in millimeter. First, the first thing that we should do when going to Autodesk sheet metal design is to have a sheet metal defaults. I will go to create a new one by clicking this icon here, and I will call it carbidal sheet, or thickness would be 2 millimeters as a drawing, and where material is simple or low carbon steel. And for the bending, this parameter is better than the B. I would choose it A, and the form punch feature or 2D sketch presentation, 2G, and here we can choose unfold rules. Then we go to relief cut. I will uh, leave them as default and choose save. Save. Then we go to carbidal sheet and OK. And then we start sketching. I will start by creating the top sketch, and this is, as I see, is symmetrical. Then it's better to start in a symmetrical line. Uh, I would sketch here, then we have a here chamfer here, and very simple. And we would make it these things constraint, horizontal constraint, use horizontal constraint when it comes to symmetrical dimensioning. I would, or another thing that you can do is to have a symmetrical line and dimension it according to the symmetrical line, which would be 100, and you do not need to divide this number to 2 when giving dimensions, and it's quite comes handy when dealing with complicated parts. I would give it dimensions as you can see, and the dimension here is, we will choose align, not align, um, horizontal, 27.5, 27.5, and 27.5, unfortunately was not correct. We have deleted. We use this format, and then this format. Fortunately was, our symmetrical line was on this and this, and then I would choose just 27.5, and then, oh, we have made mistake somewhere. The vertical, horizontal 35, leave it, and then 35, and then choose this horizontal constraint and make it constraint. Okay, and then give 27.5. That's correct now. And for the height, I would use these parameters 90, 30, and 50. So this section is 10. I will give 10 and 30. 50, and the hole would be 90. That's okay. Then we use mirror tool, select entities to be mirrored, and then select the mirror line, and then apply. Done. Then we go finish, and then sheet metal, and then select face. And as you can hear, uh, for the unfold rules, we can use default rules by call factor or by sheet metal rule on body, which is again call factor. Or if you remember on defining defaults, we could have bending parameters defined, which was not so important for me. So, okay. Then for the next part, we would design these bends right here. We have a 90-degree bend, which is approximately uh, 11 in height. So for here, it's a flange. We use flange in here, and for the reversing it, and the distance width is 11. Okay, and for the flanging height, let's guess for if it's here, it's better. And uh, for this section right here, we again use flange as defined here. And the height of this flange is 17.5. Flange here, reverse direction, 17.5. And hit OK. Then we can go to fillet, and the fillet is 7.5, 7.5, and fillet this edge and this edge. Hit apply and OK. Then for the hole, we can use automatic hole. First, if you want to make a concentric coincidence, select the face that you want to hole sit on it, and then select a circle that you want to be concentric with it. And for the rules, I can select 6, simple through all, 6, and OK. It's very simple. And for these two relief cuts, I can they are very similar to what I've done before. So I would leave it to you guys to do it as practice. And I want to design this section. This section is a kind of flange, but it's bigger. But we can modify the sketch if we want to. So we can sketch a line in this face, or we can straightly go to face and select this part. And for modifying and or sketch, I guess this tool is not available here in in Autodesk Inventor. This tool is available in SolidWorks, which comes very handy in these occasions. But it doesn't matter. We would sketch a line here. The oh, it's 17, so we didn't need to sketch a line. We would use this part, and the height is 70. The height is 50. Sorry, 50, and then hit OK, and then we use fillet, radius 25. Select this edge and this edge. Oh, hit OK, and then create a circle here, which we could use again. Let's use whole wizard, because if we try to sketch, we have to convert the sketch, we have to manually apply the constraints, which is quite time consuming. So we go to whole. I would use this, select this face, and then select this circular edge. And then the, this section is 20. Diameter is 20. So 20. Okay. And that's pretty much is it. You can follow this guideline for almost all of the sheet metal design. For 90% of sheet metal design, it's fairly simple. S- Thank you very much.